The brain is trapped inside a dark box called your skull. And although it feels like we experience the world directly, the physical reality is that your brain only ever has indirect signals to work from. It's receiving different frequencies of light waves, sound waves, and haptic vibrations from its sensory receptors. And the question of perception is, what just caused that sensation? In order to answer this question of causation, the Bayesian brain hypothesis proposes that the brain starts from its own generative model of the world. In a previous video, I've already gone into theoretically why building a generative model is the most energy efficient thing for the brain to do. So the brain has this generative model of how the world works. The next question is, what happens when new incoming sensory evidence comes in? Well, the theory goes that the brain is going to make a prediction about what is causing those sensory signals. That's also what we covered in the previous video. So the brain has its prediction about the world, but then it has the world as it really is. And really, what you experience as your present experience is some combination of that prediction combined with reality. In Bayes' language, that combination is technically called your posterior. The prediction you have about the world is called your prior, and the incoming sensory signals you have about reality is called your evidence. How these combine together is determined by Bayes' law. I'm not going to go into the maths behind the Bayes equation, because I think it's more intuitive to explain it with these visual distributions and with real-life examples. Variance in a distribution is represented by the width of the bell curve, and the width of the variance tells us how certain or uncertain that belief is. The narrower the width, the more certain the belief, whereas the wider the width, the less certain the belief. Just imagine you're a little dot and you could land anywhere inside these bell shapes. In the one on the left, you have a lot less flexibility where you could land. Essentially, you're very likely to land somewhere around that dotted line. Whereas the one on the right, it's a lot less certain where you would land. In the example I've been using, all of these distributions have had very similar variance, so they've all been equally certain. But let's imagine an example of seeing someone you think you know in a bar. The bar is crowded, the person is far away, and you can't see them clearly. You think it might be a friend of yours, but you're not sure because you've not seen your friend in this part of town before. Well, in this example, there is uncertainty in the incoming sensory evidence, and there is uncertainty in the prior belief about it being your friend. So the prior distribution would be shallow, since we don't know if it is someone we know or not, and the sensory evidence distribution would be represented by an even shallower distribution. In this scenario, these distributions combine to give us an uncertain perspective. We're not sure on whether that is our friend or not. Instead, if we change the scenario slightly so that the bar is empty and you're standing right next to the person, so you have a really good view, then your incoming sensory evidence is going to be a lot more certain. So even though your prior experience tells you it's unlikely that your friend would come here, because your sensory evidence is so precise, you update your world model, your posterior, and conclude that this is your friend. Okay, and let's alter the scenario one more time. So this time the bar is crowded again, and you're on the other side of the room. Again, you think you might have just seen someone you know. But this time, because of your Instagram feed, you know that person is currently traveling on the other side of the world. So this time, your sensory evidence is still uncertain because they're on the other side of the bar, you can't really see them. But because your prior is certain, you're going to conclude that it's not your friend and you will return to your conversation. This phenomenon of relying on your senses or your prior experience depending on which is more certain is called precision weighting. The precision of a distribution is given by its certainty or how narrow its variance is. And precision weighting is where your present experience, also known as the posterior, is weighted towards whichever input is more precise. But in perception, you can also have multimodal precision weighting, which is where you have multiple sensory inputs, because let's be honest, perception is made up of multiple different modalities. So what happens when you're trying to perceive the world around you but you have conflicting messages? Let's imagine you're trying to find your keys. The last place you had your keys was in your bag. You've looked loads in your bag, but you can't see them. But when you shake your bag, you can hear the jingle jangle of your keys very clearly. What do? Which modality do you rely on? If you rely on your vision, then you will conclude that the keys aren't there. But if you rely on hearing, then you will keep searching for the keys in the bag. In this example, because the sound of the jingle jangle of the keys are so recognizable, essentially because there's so much certainty about the precision of that sound, your perception combines those two modalities and you weight hearing as more important. A final thing to note about our senses and precision weighting, regardless of what we're perceiving, is that our different senses have different innate levels of precision. So vision, for example, is a lot more naturally precise than hearing or touch. This means that naturally we are more likely to rely on vision most of the time, which is what happens. We are fundamentally visual creatures. Okay, cool. So I hope you enjoyed that. It's important to emphasize that this is one theory for how the brain works. This video has provided a summary of one part of that theory, and the main references for this theory can be found at the end of this video. The theory explains a lot of data in perception research, but it is only a theory and there are many different ways the theory can be critiqued. If you have issues with this theory, like potential critiques, or you have any feedback about anything that I might have missed in this video, or ideas you want to see more of, then drop me a message in the comments below. Thanks very much for listening.